Hello everyone, this is program number 15 and in this program we are implementing binary to decimal number conversion using recursive function. Then first discuss what is recursive function. Then recursive function is a user defined function that calls itself again and again until some condition becomes false. Then once the condition becomes false, it will automatically terminate it from a function, or it will stop calling itself. Then to recursive function itself use the stack data structure to make call and to store all the intermediate results whenever it will make call to itself. Let us see an example how to convert a given binary number into a decimal number using recursive function. Let's start our discussion with the program. And here is an example, it is program 15 binary to decimal conversion using recursive function. Then start our discussion with the main program. Void main, then integer bin. Then you have to declare one variable as the input variable that will read binary number as a input. Then clear screen, then printf, enter a binary number, scanf %d ampersand bin. Then a printf equivalent decimal number is %d equal to binary to decimal number. You have to make call to this function as binary to decimal with the input as the binary. Then here make call to this function as integer binary to decimal and integer binary. Then here the terminating condition is when the given binary number is not divisible by 10, then this is the terminating condition. When that given input is not divisible by 10, then you have to return that bin value. Otherwise you have to make call to this function. Again you have to make call to this function binary to decimal with this value as binary divided by modulo 10 and take its remainder plus binary to decimal. That is nothing but binary number you are converted into a decimal. That's why we have to divide it by 10, but you have to consider its remainder value. This is an modulo bin modulo 10 plus binary to decimal. Again you have to make call to this function with the new value of bin divided by 10 into 2. To get or to convert that binary number into decimal, you have to simply divide that number by 10 and you have to multiply it with 2 and you will get the decimal number. This will again the binary to decimal. Here you are making call to the same function once again with the new value of binary divided by 10 into 2 to this value, and this will be repeated process until and unless this condition becomes false. And once this condition become false, you have to come out of the loop or you have to come out of the function. That is when the no more further division of that given binary number is possible by 10, then you have to terminate from this function or you can stop calling this function. Because of this terminating condition, when the binary number is not further or it is the binary number is further not divisible by 10, then you have to stop this process and come out of this function. Then now discuss our example or continue our discussion with providing some sample input to this program and check its output or monitor its output. Then for this you have to provide and sample input for a program. Here is a program to convert your binary number into a decimal number, and to this program you have to provide some sample inputs. Suppose the sample input for your the first binary number is suppose 1010, then its equivalent decimal number is 10. Similarly provide input number as suppose 111 and its binary its decimal equivalent is 7. Similarly try it for another time, that is 1011 and check its equivalent decimal number for a binary 101 is 11.